Hi, everyone. Welcome to the latest in Beacon's webinar series on how to build a new financial instrument and quickly deploy it to production. My name is Mark Higgins, and I'm co-founder and chief analytics officer at Beacon. So today we're going to look through how to build, test, and deploy a new financial product in Beacon. The example we're going to look at is an exotic derivative called a European digital option. We'll talk about the details of that in a minute. And we're going to implement this as a new financial instrument that knows its contract terms, knows how to price itself, knows how to evolve itself through life cycle events that happen through its lifetime, and also knows how to display itself in Beacon UIs. And then we'll build those UI screens and show how to deploy it all to production really quickly. One of the key messages we want to get across here is that Beacon isn't just an R&D platform. That's one of the big differences between Beacon and a lot of other platform vendors, is that we thought a lot about this whole journey from development all the way out through to production. While it's essential to have a great R&D environment, when you're working on a trading desk where you can test at scale against real production data that you can trust, that's not enough. You've got to get, once you find something that actually works, it's also essential to put that functionality into the hands of the business, right? So no one in the business is going to care if you built something really cool in your R&D environment because it's just a toy. You need to put it out into production. And there's a lot of complex enterprise technology considerations around how that works, especially in our modern regulatory environment where there's a lot of controls. So we're going to do this by looking at how do we build a new instrument? And the instrument that we're going to look at is an exotic derivative called a European dual digital option. So the idea with this thing is it's a European payoff. So on some expiration date, if two asset prices, one is an equity index like the S&P 500, and another is a foreign exchange spot level like euro dollar. So if the S&P is above one strike and the euro dollar is above a different strike on the expiration date, then the owner of that derivative gets paid $1. And if those conditions aren't true, then it's worth 0. We're going to support two different pricing models for this, just as a way of showing how Beacon implements different pricing models. We're going to look at Black-Scholes pricing, where it uses just at-the-money volatilities and ignores the implied volatility skew and smile. And then we're going to look at a slightly more advanced routine called the Gaussian copula, which does incorporate all the implied volatilities of both assets. We're also going to show how Beacon supports life cycle events for derivatives. And that's because Beacon isn't just sort of like a pre-trade pricing system, it's an entire trading system where you can book trades and manage them through their lifetime. In the case of this European dual digital option, it's got just one life cycle event, which is on the expiration date. If the option's in the money versus both those two strikes, then it turns into a cash payment. And if not, then it expires worthless. So we'll show how to actually implement that logic in Beacon instruments. So as a quick sketch of the process that we're going to walk through, first of all, we're going to look at how to develop that new instrument using Beacon's developer tools, and in particular, Beacon's IDE. Then we're going to build unit and regression tests for it and show how that works. Then we're going to implement the user interface for it and show how to make it show up in our pre-trade pricing tool called Beacon Quote. And we'll show how that also lets you use it trade management tool called Trade Blotter. This is all going to be in a development area. And so then the last step is showing how to use our SDLC, our software development lifecycle tools that are built into our IDE to deploy these changes into production in a really easy way. So let's switch over now to our IDE, and we can jump in and see how this all works. What I'm showing here is our Beacon IDE. This is kind of the main development environment in Beacon. And the programming language that we use for most stuff is Python. We can incorporate libraries of analytics from lots of different pricing libraries, but kind of the main glue language in Beacon is Python. This script shows an implementation of a class that represents this European dual digital option. It's a regular Python class. It inherits from the space class instrument, which is sort of like the shared functionality for financial instruments in Beacon that includes shared functionality like converting unit prices into position prices and stuff, and also defines the API that you need to implement if you're building a new instrument. All these classes are what we call grommet classes in Beacon. Grommet is Beacon's dependency graph framework. If you're new to dependency graphs, we did a webinar on dependency graphs a couple months ago, and if you're interested, let us know and we can send you a recording on that. But the basic idea is that dependency graphs let you efficiently link together lots of different financial calculations, cash optimally and things like that. For grommet classes, they're regular Python classes. So here, for example, is a method on this thing called index ticker, which corresponds to like which equity index market we're using. And if I want to link this method on this class to a node in the dependency graph, I have to tag it with this decorator at grommet.fn. This at grommet.fn thing basically means the method is connected to a node in the dependency graph. Some of those nodes are regular calculated values, and some are tagged as grommet.stored. Grommet.stored means this is a data method. So grommet classes don't have regular data members. They have methods that are tagged as grommet.stored, which say these are the things that get saved out to the database when you serialize one of these objects. In the case of a financial instrument, those stored values, the data elements, correspond to the contract terms of the derivative. So remember, this is a thing where I've got an equity index and an FX spot, and if both those levels are above their respective strikes on an expiration date, then the derivative pays off with $1. So we've got index ticker, which corresponds to the equity index market, the currency, which tells you what the currency pair is, the equity index and the foreign exchange strikes, the expiration date of the derivative, and the settlement date, which says, if it's in the money and pays $1, what date do you actually get the dollar in your bank account? These stored values, because they're methods, they're not just regular data members, they have default calculations. And some of them are simple calculations like returning a constant like this one. And other ones like, in this case for the equity index strike, show are calculated values. So the equity index strike, for example, defaults to the current index spot level. So let's see how that works. I'm gonna hit F9 on the script, which parses the script and defines the class. And then I can go and create a little object down here in the shell. And now I've got an object which corresponds to one of these dual digital options, and I can go and look at methods on it, like what equity index market am I using, or what's the currency that I care about. I can go and look and see what is that default for the strike price, and it's the current S&P level. And this is all plugged into an underlying data fabric, which holds all of the things like market data and reference data and different kinds of objects that let you access different parts of the market and different kinds of analytics, all using our dependency graph framework, which is why this is actually showing some numbers here because it's got a default market environment that is running and which corresponds to last night's close. Some of the values here are contract terms. Some of them are calculated values. So for example, if I scroll down a little bit, here's a method called index volatility. This is, the implied volatility for that equity index market for the expiration date and the index strike. So I can go and, ask for that guy and go and look at the interpolated volatility there. I can also go and look at other stuff like the premium of the option. So this method premium price is kind of a key method that you need to implement as an instrument developer, which tells you the price for 1 unit of that instrument in its denominated currency on the premium value date. Premium value date kind of wraps up the conventions for the date where you exchange premium if you buy or sell one of these things. So I can go and calculate the price of the option down here too. Just by asking for premium price, and it goes and it calculates. The price of this guy is like 38%. So one way of thinking about this European dual digital option is the probability that both the S&P and Eurodollar will be above their respective strike levels on the expiration. And so the kind of risk neutral probability that it's telling me here times the discount factor is 38%. One thing to note, when I ask for the price, you can see in the implementation here, what it does is it delegates the price to a helper object, this pricer object. This is an important way that we kind of separate the contract terms from the pricing logic. And it's also a way that we let clients implement their own analytics. So, when Beacon comes out of the box, it has reference analytics that wrap up our own internal, quant libraries and analytics that we think, represent market pricing. We can support multiple different pricing models that point to different analytics. And the way that we figure out which analytics to use is through a string name that defines what's the class of this pricer object that gets kind of constructed on the fly when you ask for the price. And so here's the default class name. If you wanted to write your own though, because maybe you have your own in-house quant library and you want to plug your own analytics into this, all you do is write a new pricer class in your own instance of Beacon, give it the right interface, and then point the instrument pricing at your new class. So with that, why don't we jump over to the script where I define some of these pricers. So we're going to have two different pricing models, a Black-Scholes pricing and Gaussian copula pricing. So here's where we define those classes. So first of all, there's a base class. This again is a grommet class. It inherits from this base grommet class, and it defines some common functionality like a reference back to the parent instrument that's asking for the pricing, and also like correlation lookup from our correlation market data. The first class is Black-Scholes pricer. So here I've got this dual digital pricer BS. This guy, the main method that you need to implement is premium price. And so in here, it's going to go and pull in contract terms from the parent instrument, pull in market data, and then plug it all into some analytics. Here's a second class. This is our Gaussian copula class, which does a similar sort of thing. So here again is this premium price method, and it pulls in, again, contract terms and market data. In this case, the market data is a little bit more complicated. The way Gaussian copulas work is they take the distribution of each asset price on the expiration date, the risk neutral distribution that comes from looking at all the different option prices for all the different strikes, not just the at-the-money volatility, and transforms it from asset price into a standard normal variable. And then the Gaussian copula model basically says I'm going to assume the two standard normal variables that I got from transforming those two asset prices. Those two standard normals end up being having a joint normal distribution with some correlation. So this model basically lets you incorporate all the implied volatility versus strike information. And we have a lot of stuff out of the box that does those kind of transformations for you, just as an example of the kind of analytics that come out of the box with Beacon. So if I go back to the instrument script, I can take a look at how to switch between different pricing methods. Here, if there's a method called pricer type, and this is the string name of the class that it uses. So let me toggle from our copula pricing to Black-Scholes pricing, just to show you how that works. I'm going to do an override. An override is a function of this dependency graph that lets me lay on a temporary value onto a node in the graph, in this case, the name of the class to use. And so now if I look at the pricer object, it's returning me one of these Black-Scholes objects, pricer objects. And if I ask for the price of the derivative, it gives me the price under that model. So 26% with Black-Scholes pricing versus 38% with incorporating the full volatility skew and volatility smile. So that's how you play around with or implement kind of the basics of the instrument, the contract terms and the pricing. So the next thing we're going to look at is lifecycle management. So lifecycle management basically says instruments should know on dates when there are lifecycle events, what those events are based, and figure out which, whether exercise or expire, for example, based on the market state, and then also tell you what the instrument rolls into. So the APIs you have to implement are like lifecycle types, which says what's the kind of enumerated list of supported lifecycle types for this thing. Next lifecycle date says when is the next scheduled lifecycle date. In this case, it's just the expiration date. Next lifecycle type, this is the thing that looks at market data and tells you what event it thinks you should do. So in this case, it says if both asset prices are above their respective strikes, then it's an exercise. Otherwise, it's an expire. It just returns the string. The thing that uses that string to figure out what to do is this method next lifecycle incremental positions. And so this guy basically says, if I'm due to expire, then the position effects of expiring is basically just like close myself out. Take the dual digital that I have a position on and do -1 to take it out of the positions. If it's in the money though, right? If the event type's exercise, then it says, well, what's the settlement date for my one unit of currency cash flow? What currency is it denominated in? And then it creates a new zero coupon bond instrument that corresponds to a cash payment on that settlement date. And the position effects of exercising this thing is to close out of the dual digital itself and turn into a zero coupon cash flow. All these life cycle events are meant to be P&L neutral, right? What that means is there's no P&L impact from running the life cycle event. So, for example, if the options out of the money is worth 0 and it turns into nothing, there's no P&L impact from that. If it's in the money, then the value on the expiration date of the dual digital is just its payoff. So if I trade out of something worth the discounted payoff and trade into a zero coupon bond, that's also P&L neutral. So all these life cycle events are designed to be P&L neutral. Okay, so the next thing I wanted to talk about is testing. How do we incorporate testing into this whole SDLC process? So Beacon has a really comprehensive testing framework built into it that's, at the low level based on Python's unit test framework. And so what we're looking at now is a script where I define the unit and regression tests for this new instrument. So I've got, a class here that, is based on Python's unit test stuff, but includes a lot of high level bits like, some data on which market data set to use in the tests. Then I'm going to define a bunch of tests that create a bunch of, randomly generated instances of this European dual digital instrument and run it through a bunch of tests. So I've got one test that says if one strike is really low, and the other strike isn't, then it looks like a single dual digital, and make sure that that pricing ties out. I've got a test that checks that the dual digital price is less than the minimum of the two single digital prices, which needs to be true. Some other stuff like, testing that the pricing is monotonically decreasing as I increase the strikes. A smoothness test to make sure that the dual digital option pricing is smooth as a function of the two asset spot prices and as a function of moves in implied volatilities to make sure that delta and vega are going to give sensible results. A life cycle test that checks that the life cycle events are what we expect and that they are actually P&L neutral. And a known values test. This is a regression test, so it creates 5 randomly generated instances of the instrument and prices it and compares it against a cast set of prices. And this last test is just to make sure that, if there's some change to pricing which still somehow passes all the other unit tests, that it'll, fail this one and you can see what's going on there. These tests are run, once this is out in production code, these tests are run automatically a couple times a day against the production source code. And they're also run automatically when you go and make a change to code that's being tested by these scripts. And we'll walk through that in a little bit when we look at the SDLC workflow. Next thing I wanted to look at is how we build a user interface for this. So let me open an application here. This application is our Beacon Quote application, and it corresponds to a kind of pre-trade structuring tool. So if you're looking at doing an actual deal in something, you can build a portfolio of stuff. So let me pull up, say, like a couple S&P index options here. Maybe I want to have a call spread, 4,200, 4,400 call spread for 30th of July expiration. So now I've built a little structure which corresponds to a call spread. It's got market data viewers, so you can go and see the market data that your position depends on and manipulate it. You can pull in real-time market data, run risk on it, and all that kind of stuff. So what we want to do is make this new dual digital instrument show up in Quote Tool. So let's look at how you do this. And I think this is a great example of how in Beacon we try and make things easy for developers. I'm a quant. I'm not particularly good at user interface stuff. We built a lot of functionality in Beacon so that I don't have to be. I can, have really professional user interfaces show up for stuff without having to be awesome at UI stuff. So here's the script we're looking at now is similar to the original instrument script that we had. So I've still got my, grommet method here that defines, what equity index market we're looking at. But I've added on some of the methods a new decorator called form field that says this field should show up in user interfaces. It's got a few things that you pass into it, like a category here, category terms. If we go back to Quote Tool, There's a bunch of fields up here at the top that are in blue. These correspond to the terms. It's sort of a grouping of fields that correspond to terms. There's other groupings for like market data and for pricing and things like that. I've also added a little type hint onto this thing saying it's a string that also gets used by Beacon Quote to figure out what kind of widget to show. Also, I can put in, what name does it show up? That's, what name shows up on the side here. So I can, this is also a drop-down list, by passing in choices here. This says, look at this grommet method called tickers, which I've defined right here, which goes through the appropriate directory in our file system, figures out what are all the different equity indexes that we support. And then when it shows the index ticker here, it shows it as a drop-down. So we've also got the same thing here, so you can see a drop-down list of equity index tickers. We can also look at other fields that are like market data fields. So here's one, the index spot. We want that to show up in like this market data section here. And so I'm going to tag it with this category market data and pricing, tell it what name to show, tell it what numeric format to use for it. I've also given it a little type hint to say it's a float, which Beacon Quote will then use to say I want to show this as a number. Same thing for like dates. So here's our expiration date field. And I've just given a type hint to say that it's a date, and then Beacon Quote will use that to show a date widget for that thing. I've also got like the correlation that we're using. I've added that, and I've added a few risk numbers as well, like delta and vega for both asset classes. So that's the code side of it. How do I actually make it show up in Beacon Quote? Well, first thing I need to do is get it to show up in like this list of options for different kinds of instruments that you can choose in Beacon Quote. And that comes from basically like a listing in a particular directory in the file system. So let's take a look at our underlying object-oriented file system. So, Beacon has this data fabric that underlies it. It looks like a file system in that it's got directories and subdirectories, but instead of files, it's got objects. And so here is like this ref data instrument classes directory. This is the list of things that shows up in that dropdown in Beacon Quote. So if I want to test this out, I need to add an object into that directory, but I don't want to change, this is still in development, so I don't want to change the actual database that anyone else is using. So I'm going to do something pretty cool here. I'm going to switch to a sub database, which is just used by me. So the way the sort of logically creates a new database, which is backed by the main database, and in front of it, I have a little area where I can write objects that only I can see if I'm accessing the sub database, so it doesn't affect the production data. And I've already added an object into that directory. So if I run quote tool from here, here's Beacon Quote coming up again. And so now I can go and put in demo dual digital. That's the name that I gave this instrument. And now it's going to show up in Beacon Quote. So here it is, kind of pricing parsing the stuff and pulling it all up. You can see here, on the market data panes, it's also figured out that because of using the dependency graph, it'll figure out what types of market data is exposed to, and it'll show me market viewers for all those different kinds of market data. But you can see here it's shown, it's got the fields exposed in the way that I wanted it to. It's showing, market data fields, unit price fields, and position level prices and risk numbers. So it's pretty easy for me to put that together without being, a UI expert. I can kind of quickly have it show up. Another interesting thing I can do is kind of solve for functionality inside of Beacon Quote. So if I wanted to say like, what equity index strike should I use to have the price be 40%? All these fields are in yellow are ones that I can overtype and have it solve for stuff. Down at the bottom here, it gives me the list of things I can choose to move around when I'm doing that solving. So for example, if I've got index strike selected now, here's the current index strike. If I change this to like 45%, then it'll go and solve for the equity index strike to make the price exactly 45%. The way I implement that in the code, if we go back here, first of all, if I look at like the premium field, I have this solve for flag in the form field. That makes it show up as like a yellow field here indicating it's something that I can overtype and have it solve for. And if I go back up to where I define, the index strike, the way I tag it as a field that can be one of the things that you move when you're solving is to give this tag solve domain. This tells you when you're doing the numerical search, what are the low and high elements of the range to search over. And that lets me implement that solve for functionality really easily without me having to do a lot of user interface stuff. Another application that we have is our trade blotter application. This is an application that you use to kind of view your existing trade population in real portfolios and book trades and run risk on your whole portfolio and things like that. And I can go and add a new trade in here. Here's my demo dual digital again. And without doing any other work, I can have the trade entry screen for my demo dual digital show up in Trade Blotter using that exact same set of form fields that I implemented before. It looks a little different because it has a different layout for trade entry, but I don't have to do any extra work to have the derivative show up in Trade Blotter and be able to use it there. So that's kind of a tour through the how do you add stuff as a user interface. The last thing I wanted to show is how you actually go and deploy this stuff to production. So on the left here in our IDE, we've got a view of all the different version control repositories that are all the different Git repositories that are exposed in this environment. And this is kind of the starting point for workflow. So the first thing that you do when you want to deploy your change into production is create what we call a feature branch. A feature branch is really just a Git branch. And so here I've got this Git branch feature.mgh.demo dual digit. I can go and create a new one if I want. And so the first thing I need to do is commit some stuff into version control. So here I can go and stage this guy. And then add some sort of commit message. And now I've got it committed into this feature branch, but it's all still local. And I can go and then go and create a review for this change. And what that's going to do is package up this Git release, deploy it out to the main Git repository so you can see it. And then I can go and look at kind of the state of this review. And this is another stage in this workflow for getting something deployed. So here I can go and see, what changes I've made inside of this review, and also see what tests have run against this thing. So whenever you create a new review, it automatically in the background runs all the tests that are affected by the code that you're changing. And make sure that those are passing. This is also where you control sign off. So this list of reviewers up here, every script that you have is tagged with a group which corresponds to who are the people who own this code and can review the changes for it. And so someone from this list needs to come in and review these changes and explicitly sign off on them. And once they do that, then back in the IDE here, under deployment, it would say your changes are ready for deployment, and I can click and have them deploy to production right away. So that's the end of the demo. So in summary, the things to take away, Beacon isn't just a great R&D environment. It also is designed to give you this really smooth path to production. Creating a new instrument means defining, a class that defines the contract terms through those grommet stored values, implementing pricer classes to wrap up your analytics. And again, as a client of Beacon, you can take our out-of-the-box instrument classes and write your own pricer classes that wrap up your own in-house quant libraries and analytics and things. You have to define lifecycle events and how do you handle those in terms of what the position effects of them are. Build unit and regression tests that get run automatically when people make future changes to the code. Implement user interface support by adding those form field decorators to different grommet methods, and that kind of transparently exposes the instrument in a bunch of different out-of-the-box Beacon applications. And then follow the SDLC workflow to take the changes from your developer area and deploy it to production. And one of the big benefits of our SDLC workflow process is that it lets you have an iterative development and deployment process. So Beacon's SDLC workflow isn't built around kind of infrequent monolithic releases like once every 2 weeks or once a month or whatever. It's built on having lots of little atomic releases that happen all the time. And that's really powerful on a trading desk where, I'm sure as most of you know, traders, salespeople, portfolio managers don't have always like a great concrete view of the requirements that they have. They'll have some sort of fuzzy view. So you want to be able to take their, take an idea, build a version 1 of it, get feedback, implement that feedback, put it at a version 2, and keep on cycling through that. And you want to have that iteration cycle be as short as possible. And Beacon's really designed to let you do that while also still satisfying all the control requirements that we all have to live with in our kind of modern regulatory environments. So with that, I'll stop and happy to take some questions. All right, one question is, how does model risk management play into this process? It's a really good question. So I sort of skipped over that a little bit. Beacon, this because it's there's a lot of stuff there. Beacon supports model documentation. So Beacon comes out of the box with documentation environments, where you can see our documentation that we provide and also build your own. And you can build comprehensive model documentation inside of that environment. You can also have, as reviewers of your code, as part of the model risk governance process, you can have a model risk team be people who are required to approve changes to instrument changes, so that they can be in the workflow for deploying model changes in production. You can also do much more comprehensive testing than what we looked at. Beacon has access to the full market data environment and full market data history. One of the common things people want to do with model testing now is hedge back testing. So say I've got my exotic derivative, how would that pricing model have performed historically if I'd put on a position and then use the model to tell me what hedges to do, put on those hedges, and then kind of evolve that forward through time? Does that give me a nice tight hedged P&L distribution, or does it not work very well? So in Beacon, because we have, as part of the data environment, access to all that history and all this really nice high-level functionality, it's easy to do those kind of hedge back tests. All right, any other questions? All right, one other question. Do analytics need to be in Python? So the pricer script that we looked at basically implemented the pricing logic for that dual digital. It's just Python code, which is okay for this one because the pricing routines were relatively quick. That said, if you want to implement pricing routines that are in some other language, that's also really easy. So, a lot of quant libraries are written in C++. To expose those in Python, basically what you do, or in Beacon rather, is get a Python wrapper for your C++ library, which you can do lots of different ways. We use Swig internally, but there's lots of other ways of doing that. They're all supported in Beacon because it's just Python code. And then in the premium price method that you implement for your pricing class, basically what you do is pull in all the market data and contract terms from the Beacon environment that you need, marshal those into the appropriate objects that you need to pass into your pricing library, pass them in, get a price back out, and then you return it. So we have clients who've done that with C and C++ libraries, with .NET libraries like C# and stuff, with R, with Java, lots of different languages, MATLAB. So it's pretty easy to incorporate, other kinds of analytics into the pricers. All right. Another question. How do the stored values translate to the data model? Great question. So the follow-up was, is there one table per instrument type? So Beacon's underlying database is not a relational database. That doesn't mean you can't connect to relational databases in Beacon. We have support for all that, but kind of the native data fabric that we use for serializing deals and instruments and things, is an object-oriented data fabric. How that works is those stored values that we looked at, those tag which methods are the data elements. And then when we save an object to the database, it basically creates a little JSON structure that just has, for each one of the data elements, the name of it and the value, and that's what gets saved out to the database as an object with a particular name. And then when you load up that object, it pulls in the object, pulls in that little JSON dictionary that says what the stored values are. There's also, when you save it out, there's also a thing that saves out which class type it is. And so it basically says, construct a new instance of this particular grommet class and set on these stored values. All right, another question: how do you integrate other data sources, for example, Bloomberg? So, ultimately, Beacon accesses market data through time series interfaces. So some of the objects in that database are well-named objects that correspond to time series, like a time series for the S&P settlement price each day. Those time series interfaces can get data from wherever you want to get them to. They don't hold the data; they're just interfaces to it. And so they can go and load it from time series that are stored natively inside of Beacon, or construct queries on the fly to go and access other stuff. And we've built a bunch of integrations with data vendors like Bloomberg. Maybe one more question. The demo is leveraging knowledge about Beacon and its underlying library and data structure. What's the typical time needed for new users to familiarize themselves with Beacon for doing their own kind of similar custom work? It's a great question. It usually takes, depends on the person. Some people come to this with a background in similar kinds of environments that, like SecDB at Goldman Sachs, or Athena at JP Morgan, or Quartz at Bank of America. For those kind of people, because this is quite similar in structure to a lot of those, it just takes a few weeks to kind of, get up to speed. For people who come at it without that kind of background, the learning curve is a little bit longer, maybe a month and a half or something to get to the point where you can be comfortable, doing development and using all the different Beacon tools. And we have a lot of documentation that helps people through this, whether it's online guided learning, through courses and videos, or, different levels of documentation that come out with the platform. All right, so maybe we'll stop there. I just wanted to say thank you, everyone. Hope you found this interesting, and if you like, we can, send you a recording of this if you, if you drop us a note. So thanks again, and goodbye.